All right, welcome back, everyone. In today's explainer, we're taking on an absolute beast of a math problem from the November 2023 higher tier calculator paper. Specifically, we're going head-to-head with question 21. Now, I know at first glance, this question looks completely intimidating, right? I mean, it takes algebraic expressions, drops them right into the middle of a Venn diagram, and then throws conditional probability into the mix just for fun. But hey, don't worry, we're going to decode this giant puzzle together. We'll be using the exact wording directly from the official mark scheme to unlock all 4 possible marks, step by step.
So, here's our game plan for this explainer. First up, we'll break down the Venn diagram problem itself. Second, we'll find the total number of gold medals. Third, we're going to form our equation. And finally, we'll substitute our values to get that final answer. Let's dive in.
Okay, starting right off with section 1, the Venn diagram problem. So here's the exact problem statement that sits next to our diagram. It says, given that the metal is gold, the probability that the metal is English is 2 over 11. Work out the number of metals in Vicky's collection. Now, I really want to emphasize that very first phrase. Given that the metal is gold is literally the anchor for this entire problem. It's basically screaming at us that we aren't looking at the whole collection of metals right now. We only care about the gold ones. And this brings us to what these sets actually look like mathematically. So set A is our total English metals. That entire left circle is made up of the English-only section, which is 7x minus 11, plus that intersection right in the middle, which is x. Set B, that's our gold metals. That whole right circle is the gold-only section, 5x minus 3, plus that exact same intersection, x. Visually pulling these overlapping sides apart in your head is absolutely crucial. You have to understand the difference between the whole circles and that shared space in the middle. Right, let's move on to section 2, finding the total gold medals. We've got a total of 4 marks up for grabs here. As you can see on our checklist, the path to a perfect score on this question involves 3 process marks, the P1s, and 1 final accuracy mark, the A1. We're kicking things off right at process mark 1. To secure that very first P1 mark, the exact wording from the mark scheme says we get it for total number of gold equals 6x minus 3. If you write down that expression, boom, you get the point. So how do we actually find it? Well, it just comes down to a super simple algebraic combination. We just need to look exclusively at set B, the gold metal circle. First, spot the intersection, the metals that are both English and gold. That's x. Next, grab the gold-only metals, which is 5x minus 3. Now just add them together. We take x, add it to 5x minus 3, and when we combine those like terms, 1x plus 5x, we simplify it right down to our target, 6x minus 3. And just like that, we've hit the exact requirement of the mark scheme and bagged our first mark. Easy, right? Moving right along to section 3, forming the equation. Checking our checklist, that first P1 is secured. Now we're aiming straight for that second process mark. For this one, the mark scheme specifically awards a point for forming an equation. The exact example they give is x over 6x minus 3 equals 2 over 11. But they also list a couple of other acceptable answers. You can use the unsimplified denominator, so writing x over 5x minus 3 plus x equals 2 over 11 works too. Or if you jump straight into the cross-multiplied version, they'll accept that as well. It all perfectly links back to our very first clue, given that the metal is gold. Let's walk through how this builds into the actual solution. Because we are specifically given that the metal is gold, our denominator, our total possible outcomes, is strictly our total gold metals, which, as we just figured out, is 6x minus 3. So, step 1, identify the numerator, the metals that are both gold and English. That's x. Step 2, pop x over the total gold metals to get the fraction x over 6x minus 3. Step 3, set that entire fraction equal to the probability they gave us in the text, 2 over 11. Actually, writing that exact setup gets you the mark right there. But obviously, we got to keep going to find the actual value of x. So step 4, cross-multiply. 11 times x is 11x. 2 times the quantity 6x minus 3 gives us 12x minus 6. So our equation is 11x equals 12x minus 6. Finally, step 5, we solve for x. Subtract 11x from both sides, add 6 to both sides, and we get a wonderfully clean result, x equals 6. All right, the final stretch, section 4, substitution, and the final answer. Let's update that checklist. We've got 2 P1 marks firmly in the bag. We are literally 2 steps away from acing this entire thing. For this third mark, the mark scheme explicitly asks for correct substitution of their value into all expressions. Now listen, a really common trap here is to just plug x into one or two parts of the diagram and think you're done. But the question asks for the total number of metals in Vicky's entire collection. That means we have to plug our brand new x equals 6 into every single region of that Venn diagram, the whole shebang. Let's break this down systematically so we don't leave a single metal behind. First, the English-only region, 7x minus 11. That becomes 7 times 6, which is 42, minus 11, that gives us 31. Next, the intersection, the both category is just x, so that's simply 6. Then, the gold-only region, 5x minus 3 becomes 5 times 6, which is 30, minus 3 leaving us 27. And finally, do not forget the metals sitting completely outside the circles. The diagram explicitly tells us there are 34 of those. So for our total calculation, we just add all four distinct regions together. 31 plus 6 plus 27 plus 34, and doing that full substitution secures your third process mark. And when you add up 31, 6, 27, and 34, you get 98. Writing down 98 scores you that final accuracy mark, the A1. You've completely decoded the puzzle and grabbed all 4 marks on a seriously complex question just by following the exact steps from the mark scheme. Think about it. You just conquered a multi-layered problem combining geometry, logic, algebra, and conditional probability. It really goes to show that if you just break down the visual data and follow the mathematical clues step by step, no question is impossible. So, I'll leave you with this. If you can crack the code of conditional probability disguised in algebraic Venn diagrams, what other mathematical puzzles can you confidently unlock next? Keep that focus, keep tackling those challenging diagrams, and I will see you in the next explainer.